Welcome back, my dear students. In this session, let us learn part 1 of chapter number 5, data handling. Chapter number 5, data handling. Looking for information. In your day-to-day life, you might have come across information such as A. Runs made by a batsman in the last 10 test matches. B. Number of wickets taken by a bowler in the last 10 ODIs. C. Marks scored by the student of your class in the mathematics unit test. D. Number of storybooks read by each of your friends, etc. The information collected in all such cases is called data. Introduction. In various fields, we need information in the form of numerical figures. Each figure of this kind is called an observation. The collection of all the observation is called data. Some important terms are defined below. Data. A collection of numerical facts regarding a particular type of information is called data. Raw data. Data mostly available to us in an unorganized form is called raw data. Raw data can be grouped and presented systematically through group frequency distribution. Bar graph. A bar graph is a pictorial representation of the numerical data by a number of bars, uniform widths with different heights, erected horizontally or vertically with equal spacing between them. Histogram. Group data can be presented using histogram. Histogram is a type of bar diagram where the class intervals are shown on the horizontal axis and the height of the bar shown so the frequency of the class interval. Also, there is no gap between the bars as there is no gap between the class intervals. Next is pie chart. A pie chart is a pictorial representation of the numerical data by non-intersecting adjacent sectors of the circle such that area of such sector is proportional to the magnitude of the data represented by the sector. Central angle of a component is equal to value of the component divided by sum of the component value into 360. Next is probability. Probability of an event is equal to number of outcome that makes an event divided by total number of the experiment. When the outcome are equal, one or more outcome of an experiment make an event. Class interval. Each of the group 0 to 10, 10 to 20, 20 to 30, etc. is called class interval. Class limits. Let us consider the class of 10 to 20. Here, 10 is the lower class limit and 20 is called the upper class limit. Range. The difference between the highest and the lowest values of the observation is in a data is called the range of the data. Next is tally marks. Frequency distribution table involve the use of tally marks for counting purpose. We use bars known as tally marks. We can put bar like that. 5 we can put bar like that. These are called tally marks. Next is class mark. Upper limit plus lower limit divided by 2. This is class mark. Next is graphical representation. A. Bar graph. A bar graph is a pictorial representation of the numerical data by a number of bars of uniform widths with different heights, erected horizontally or vertically with equal spacing between them. B. Histogram. A histogram is a graphical representation of a frequency distribution in the form of rectangles with class intervals as base and heights proportional to the corresponding frequencies such that there is no gap between any two successive rectangles. C. A pictograph. Pictorial representation of the data using symbols. Double bar graph. A bar graph showing two sets of data simultaneously is called double bar graph. Circle graph or pie chart. We follow the under mentioned steps to draw pie graph charts. Number 1. From the given data, we find the total number of the frequencies. Number 2. For each variable, we calculate the angle of the sector. There is angle at the center of the circle. This angle is called centered angle. Centered angle of a variable is called to frequency of the variable divided by total of frequency into 360 degree. Number 3. We draw a circle of convenient radius. Number 4. Draw the sectors corresponding to the centered angle calculated in step 2 above. Thus, we can draw a circle graph or pie chart. Now, exercise 5.1, question number 1. For which of these would you use a histogram to show the data? A. The number of letters for different areas in a postman's bag. B. The height of the competitors in an athletic meet. Number C. The number of cassettes produced by 5 companies. D. The number of passengers boarding trains from 7 a.m. to 7 p.m. at a station. Give reason for each. Now, solution. We represent the data by a histogram if the data can be divided into class intervals. Here, only in case of B, that means this B, and D, that means this class interval exists. So, a histogram is suitable for B and D. Now, question number 2. The shoppers who come to a departmental store are marked as man M, woman W, boy B, or girl Z. The following list gives the shoppers who came during the first hour in the morning. WWZ like that it is given. Make a frequency distribution table using tally marks. Draw a bar graph to illustrate it. Okay, now let us solve this question. Now, solution. The frequency distribution table for the above data is given below. Shoppers, we have to make a table like that. Shoppers, tally marks, frequency, there is number of shoppers. Now, shoppers are W for woman, M for man, B for boy, Z for girl. Now, tally marks. So, to put this tally marks from this table, we have to count how many W's are there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, and 28. There are 28 are there. So these are the tally marks. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, and 28. Like that, we have to put the tally marks. Like that, M should be count here, and then we have to put the tally mark here, and B also we have to count from here, and we have to put the tally mark, and G also we have to count from here, and we have to put the tally mark here. So this is 28, and here the tally mark is 15, here tally mark is 5, here tally mark is 12. Now total, here if we add all together these frequencies, we are getting 60. Next is, let us represent the above data by a bar graph which is given below. So this is x-axis, this is y-axis, and here we are marking 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, and so on. Then this is number of shoppers, and this W for woman, M for man, B for boy, Z for girl. Then for this W, the frequency is 28. So the mark 28 is here. So this bar graph must reach to this 28. Next, M for man, and number of frequency is 15. So here the marks are there, and this is 14, this is 16, and the middle is 15. So this bar graph must reach up to this 15 mark. Next, B for boy. So boy's frequency is 5. So 2, 4, 6. Since boy is 5, here is 4, here is 6. The middle is 5. So this bar for B must reach the height of 5. Next, Z for girls, and frequency is 12. So here is 12. So this bar must reach up to 12, this mark. And these are the shoppers, and this is called bar graph. This is the bar graph. W for women, M for men, B for boys, and Z for girls. And here this represents the bar graph of this table. This table. Question number 3 and question number 4 are same as question number 2. So now next question, let's try question number 5. This. Let's study the question. Question number 5. The number of hours for which students of particular class watch television during holidays is shown through the given graph. Answer the following. Roman number 1. For how many hours did the maximum number of students watch TV? Roman number 2. How many students watch TV for less than 4 hours? To answer this, we have to observe this table. And by studying this table, we have to answer the questions. Now, Roman number 3. How many students spend more than 5 hours in watching TV? Okay, now let's try this. Here you see in this histogram, this is hours of TV watched per day, and this is number of students, and these are the bars. Now let us answer question number Roman number 1. For how many hours did maximum number of students watch TV? So Roman number 1 is, for how many hours did the maximum number of students watch TV? So when we observe this bar, this is the highest bar, and this highest bar is, you see, this is hours of TV watched per day. Here is 4, here is 5. So the answer is 4 to 5 hours. Now solution. The maximum number of students watching TV is equal to 4 to 5 hours. 4 to 5 hours. Now Roman number 2. How many students watch TV for less than 4 hours? So this is 1 hour, this is 2 hours, and this is 3 hours, and this is 4 hours. And for this Roman number 2, we have to find out how many students watch TV for less than 4 hours. The time that is less than 4 hours is 3, 2, and 1. That means 4 plus 8 and plus 22. So to solve this Roman number 2, we have to add together 22 plus 8 plus 4. So 4 is here, 8 is here, 22 is here. So 4 plus 8 plus 22, then we are getting 34 hours. Now Roman number 3. How many students spend more than 5 hours in watching TV? Here is 5 hours. More than 5 hours means 6 and 7. So from 5 to 6, here is 8. From 6 to 7, here is 6. So to answer this Roman number 3, we have to add together 8 plus 6. So number of students watching TV for more than 5 hours is equal to 8 plus 6. Then we are getting 8 plus 6. There is 14 hours. Now exercise 5.1 is over. Okay, for today let's stop here. All of you, thank you.